lesson, we have these 6 questions. And at the end, we also have our own questions again.
Okay.
So which questions would you like to solve?
The first, third, and the fifth. With the odd number.
Okay.
So I'll start first.
The first question is integral 6 secant square x minus secant x.
And don't forget the bracket.
X. Okay, these 2 brackets together. And at the end, we have the dx.
So first, we will need to separate.
Yeah.
So we can put the 6 in front.
For the first one, right?
Yes. Secant, last time we already talked about it, it's actually tangent.
So that's the 6 tangent x.
Now we change these two to the secant, which is 1 over cosine, and tangent, which is sine over cosine. We also can combine it.
So it will be a sine x over cosine square x. And then behind there is the dx.
We can put the sine x over here. And don't forget your constant.
Well, would you want to put a prime?
Yes.
So for this sine x, it can go into the dx, right?
Okay.
Sine comes from the negative cosine.
Okay.
Your negative?
Become positive. Like this?
Okay, are you sure?
Okay. Now the second way.
Well, cosine. Cosine, are you really sure?
Okay.
Okay, so let's see. So here cosine, and this is the cosine to the power of -2. Well, what is cosine? What is 1 over cosine?
So that means that for more step.
To make it more perfect.
Yes. Wait, second.
Secant? Is there a square? No, right?
Yes. There's no square. And this is something that weird, you know, because this effort is secant and tangent together, unless it's still a secant.
And there's a tangent there.
Oh, that's the other side.
Okay, so next we'll move on to the second question,
Okay.
which is the integral bracket cosecant square x plus x square root 3x bracket dx. So for this, we also separate them, which will become the integral cosecant square x dx plus the integral this x square root 3, and here's the x to the power of half, and here's another dx, right?
Okay.
So you'll see cosecant is actually a negative cotangent.
Yes. While secant is a positive tangent.
Like this. So
Okay.
what did you realize about this? X and x to the power of half. You can put them together, which will then become x to the power of 3 over 2, right?
Right.
Okay, so for this negative cotangent x, then your plus. So this x will be to the power of 5 over 2. So x to the power of 5 over 2, this comes down, you need a 2 over 5, right?
Yes.
2 over 5, and you need that square root 3. So it's a 2 square root 3 over 5.
Okay.
Then here you plus the arbitrary constant.
Okay.
Next, on to the third question. The third question is integral bracket cosine bracket 3x plus 1 bracket plus secant square bracket x over 2 bracket the square bracket. At first there was a normal bracket, then a square bracket, then at last the dx. Square bracket. So for this first step, say separate. D So like this, right now we need to make the things inside the D the same as the things inside these, the cosine and the secant, right?
Yes.
And remember, for example, the plus 1, it doesn't matter because it's a constant.
So that here we'll need to minus 1.
Are you missing something?
Of course.
D and then another D.
dB. Since here need x over 2, need 1 over 2, so reciprocal, which becomes a 2.
Continue.
Now we integrate, right?
Of course. So cosine comes from a sine, yes. Secant becomes tangent. What's missing? The last but not least, the arbitrary constant, right?
Okay. Now
Question 4 is integral bracket cosine square root x over square root x plus cosine 3x over sine square 3x here bracket dx. Okay, so for this, we separate. So this will be an integral cosine square root x over square root x dx plus integral cosine 3x over sine square 3x. Then here's the dx. And also for the square root x, the 1 over square root x, which is actually x to the power of negative half, if you put it in here, so here is a cosine square root x, and here can be a d square root x, right? But remember, when you differentiate this, there will be an extra half. Half, we will need a 2 over here.
Yes, because reciprocal.
Then your plus. At this part, cosine 3x comes in, right?
Yes. So it will come in.
So this is a 1 over sine square 3x. And then here is a d sine 3x. But remember, here you need a 1 over 3, right?
Yes.
And then for this, you can start integrating, right?
Yes.
So for this, cosine square root x, it comes from a sine. So there's a 2 sine square root x. Then your plus. So for this comes from the sine to the power of negative 1. And here's a 3x, right?
Okay.
And then here, 1 over 3. And here is a negative, right?
Yes.
Then here plus the arbitrary constant.
Okay.
So here, what can you change? So this inverse sign will become?
Inverse sine will become cosine. I mean cosecant.
Okay, so next is okay. So next, on to question 5. Question 5 is integral bracket cosecant to the power of 6x cotangent x plus sine to the power of 4x cosine x bracket dx. Okay, so for this question, similarly, we also separate, right? And so it's this part and this part, correct?
Okay. So separate.
Yes, so we will integral cosecant to the power of 6x cotangent x dx plus the integral sine to the power of 4x cosine x dx. So then for these, you will change, right? So cosecant becomes a 1 over sine. Cotangent is a cosine over sine, right?
Yes.
Then your d. Yes. the dx. Then you will plus. So for that,
Actually, the cosine can go here.
yes. But will you need anything extra?
Of course not.
Your d. Then equals. So for this part, the cosine x can also come in, right?
Okay.
Integral
And you need nothing to. Well, you can actually write those in another way. You could already first calculate those parts.
then are you missing something? And then you can change this to, remember, inverse sine is a cosecant. Can you write it bigger? Bigger, please. Okay, so next we'll be on to question number 6. Question number 6 is integral bracket tangent x secant to the power of 5x plus cosine to the power of 3 5x sine square 5x bracket dx. So right now for this, we also separate. So here we will have an integral tangent x secant to the power of 5x dx. Then we can plus the integral cosine cube 5x, the sine square 5x, and then the dx. So can I just erase the third question?
Okay.
Okay, so right now for this we can change it to another form, right?
Yes.
So this integral tangent x is actually sine over cosine, right?
Okay.
Okay, below here, the secant is 1 over cosine, right? So here's one of the sine. But how many of these cosines? There are 6. Because the 1 and this 5, which makes 6, right?
Yes.
And here's the dx. Then you will have plus. So this part, we can use the sine square x plus cosine square x equals 1.
Okay.
So which one would you change? Would you change the sine or would you change the cosine?
I will change the sine.
Okay, so let me tell you.
I mean cosine.
Okay, so let me tell you what will happen if you change the sign. If you change the sign, so then there will be no more to change, and which makes solving very hard.
Okay.
If you change the cosine, you can leave one more cosine, so that you can change here into the sine.
Okay.
Okay, so for this, then your plus, we have this cosine 5x, then this bracket 1 minus sine square 5x, and here bracket, and then here is the sine square 5x dx, right?
Right.
So like this, then you can change it.
Yes.
So for this part first, it will be integral cosine to the power of negative 6x, and here's the d. But remember, this is a sine x. When you change it to a cosine x, here you have a negative. Then your plus. So right now over here we have 2 more. So firstly, this for these two both have the d sine 5x, right?
Okay.
So d sine 5x, because I here don't have a 5, so you need to 1 over 5, right?
Okay.
Then here you have the integral. So here 1 times this is still a sine square 5x, right? Then here's the dx.
Yes. Yes.
dx
But the x need to change
to
to 5 sine 5x.
and then after that, here you have to minus, right?
Yes.
So you'll minus the 1 over 5. And here remember these 2 times. Sine square 5x, this whole thing square.
Okay.
Like this.
Yes.
Okay, so then here we can calculate. Okay?
Okay.
So here will be a negative. Will this still be a negative? Let me show you. Cosine here to the power of negative 5x. Negative 5 come down. You need a negative, right? But here's already a negative,
So
right?
negative, negative, positive.
But you need a negative there, so you cannot put anything in front, right?
Yes.
Except that you need to divide the 5. So it'll be a 1 over 5, right?
Yes.
Then you'll have this part here, plus the 1 over 5, this thing, what would you have? So here, first is the sine to the power of 3, 5x, right?
Okay.
Then this 3, later will come down, right?
Yes.
So 1 over 3, right?
Yes.
1 over 15?
Yes, because there's an extra 1 over 5.
So here you minus, here will be the sine to the power of 5, 5x, right?
Yes.
So here 5 comes down, you need to divide that 5. So 1 over 5. So here will be a 1 over 25.
Correct.
Then at the back, you have to plus the constant. Am I right?
Yep.
Okay, so is everyone clear of these?
But wait. 1 second.
Yes?
Still got our old questions.
Yes. So firstly, is everybody clear of these? These 6 questions.
What's our question 3?
But remember, here cosine, you can also change it to a secant, right?
Second. Yes. So not yet finished for the first part. Okay.
Like this, okay? So is everybody clear?
Okay.
Okay, so can we erase everything?
Okay.
Okay. So right now, let's give our own questions. So I'll write my question for you here, and you will write your question here, okay?
Okay.
Okay, remember these questions are actually related to these trigonometries. And most importantly is the integration.
Yes. And now we haven't learned exponential and
Logarithm.
yes. And these are the same kind of question as
What we have done.
yes.
So these are actually those questions that can involve a lot of these, right?
Yes.
So these, because it's about the trigono, so there can be like sine, cosine, tangent, cotangent, secant, cosecant.
Yes. And we could use any
of these like operations like plus, minus, times, divide, or even these powers.
yes.
So for example, this question,
And for example, this question.
okay, so I'll just write this above.
Okay.
So right now we'll start solving.
Okay. So there don't have a square or have a square. Over there don't have a square. That's it. Okay, have a square. Just write it a little bit more above and that's it.
Please write it properly. Wait, so for this part, here this sign to the power of 4x. Here, why is that still to the power of 4? It should be to the power of, you mean 3, right? Because that this is a negative already. So because that is a 3, you need a, and also, yes, that's a plus. Then, okay, so are you sure that that's the answer?
Okay.
Okay, so that is the answer. So are you clear of these two questions?
Yes.
So can we end here?
Okay. Next time we'll continue this lesson.
Okay, so we'll stop here.
Okay. Bye.